Good evening, ladies and gentlemen. We need to continue with our basic Rhino course. We left off at control points and offsets, if I can remember correctly. Today we're gonna look into, we will not look into the offsets on surfaces. Surfaces we're gonna touch later. We're gonna look very quickly in extending curves, and then we will do this whole section here, hopefully. There's some very interesting tools in there, like rebuilding curves. It's something I use very often, not just in Rhino, but also in Grasshopper. If you have any question, by the way, if you have any question, suggestion, any topic you want me to cover, I'm always up for it. Just drop me a line in the notes. Okay, extending curves. Yeah, I took the curve tools toolbar here, so it's easier to go through. It's more, gives a better overview, and I can use the other functions as well. And then I created a line, an arc, and a curve. And yeah, let's use the extend function. And annoyingly, there's of course more in there again. So let's do this. The extend function has actually a lot of different modes. For now, let's go through like this. So if I click this here, then you can see you have again two options: natural and to boundary. To boundary means if there's another line here and I want to extend my curve here, then this would be my boundary. So let's start this again. Extend curve. To boundary would mean I would either type O or I click here. O is the underlined letter, so that what I would click or press. So if I click O, then it asks me for the boundary and select curve to extend. And the command stays on, so I could continue clicking. And if I click right click, if I do a right click or escape, then the command is finished. That already covered the first two. So extend curve to boundary. If I don't use boundary, then I can just select curve to extend. And then I can basically drag it wherever I want to extend it to. End of extension or end extension length. So I could put a length. Center, I don't actually know what that means. Extend it to the center. Ah, I see. So I can actually, oh, that's cool, because that I didn't know. And then I can still choose the to boundary function. So basically, the type is natural, that you can change that as well. So let's do that first. Natural or line, arc, or smooth. Line is just continuing in a line from the angle or the orientation of the endpoint. That would be the angle of my line then, basically. So if I go back and I type here line, then it will just continue like this. And same here. Again, if I use the extend line, if I use arc, then it will continue as an arc. And that's interesting because 2-point, I can choose a point where it goes. I can again choose the boundary. And the center, what I just realized, I can choose its center. And then I could do this. That's quite interesting. So I can choose the radius, and I could also type the radius. If the radius is 20, then it would do this. Connect, I think we saw that already. We did that before, so we don't have to do it again. And here, basically, this is the same commands we're already choosing. We're choosing either smooth, extend by line, extend by arc, create an arc, extend by arc and keep the radius. So that would be if I have an arc with a certain radius, then this would keep the radius. Let's kill that and let's move on. Adjust closed curve seam. That's really important. So wherever you have a curve, a closed curve like this, you're gonna have a seam. Somewhere is the seam of that curve. So if you choose the analyze direction, but yeah, you analyze direction and then you can, okay, when I click then it's flipped, but my seam is still the same. And what that tool does is it can adjust the seam. And that tool allows you to adjust the location of that seam in this closed curve. Not just that, so it allows me first of all to move it around, but it also allows me to flip it. If I click here, then it asks me to select the curve and then enter, and then I can drag this and you can see I can move it here. And now my seam is here. This is very, very, very important if you have something like this and you want to tween between these curves. Let's make that a bit smaller because this doesn't make sense. If I set now a number, I want to tween between these curves, meaning basically the average. For example, if I would have one curve and at the moment I have a number which is 1, means there would be one curve in between and it should actually look like this. It would be basically always placed into the center, halfway between that inner and outer curve. So that's what I want to achieve here with this. When I do this, then that happens. And it's because the seam is not placed properly. So first of all, this seam is here and it's pointing that direction. And this seam is here pointing this direction. I would flip it, maybe that already helps. So if I do that again, not much. So let's try that again. Let's try this. Yeah, now it worked. So both seams are in the same direction and they are on a similar spot. And that creates a perfect intermediate curve. And then I could place more. Number 3. Yeah. And you can do the same in Grasshopper. So let's try it. Let's do that. So let's bring the curve. Let's link the curve here. And now we say seam here. That's one. Adjust the seam of a closed curve. So what I could do is I did that before. I used the parameterize function here. So I created this curve is going to be parameterized. Let's hide this original one. That curve believes it's only 1. The length of the curve is only 1. And now I could put a slider here. And I could actually show the seam. Let's check. With the endpoint function, I could. So you could change the seam. Let's just keep it for now with this. And yeah, I could do the same with this one. Let's bring both in. Yeah. So what we also could do is to have a point in space, because if I want to align that seam and this seam to be on the same spot, then what I can do is I can use this tool here, the closest point to a curve, and I can select a point. I can select this point here, and then I can choose the curves. I can put these in here, and now I have these as the closest curves, as the closest points to the curve, and they have a value. They have a parameter value, and instead of like putting a slider in here, I can actually use these values here. And that creates my aligned points. If I would now move that, you can see that it moves along. It kind of moves along. And that's why it's good to know to adjust the seam, that they are able to adjust the seam. Because, for example, now if I loft this, if I loft these curves, then they are perfectly aligned. Whereas if they are not aligned, then first of all, it already looks different. Now, if that would be even flipped, then you would get something like this, which is not correct. That's not what you want. Yeah, so that is basically moving the seam. And we could even add more. So that's yeah, it's pretty handy. Curves from two views. I never used this, but let's try it. Let's do it. So for example, I never use it, but it's really cool. So I have two curves. This one is an arc in top view, and this one is an arc in front view. And if I use that command, curve from two views, then I can choose this one and this one. Then it created me this one. Match curve directions. Now that we actually could have used the one we did before. Maybe let's go back. No, for example, I have this, and then I have this, and then I have this one. If I use the analyze tool, you can see that this one goes that direction, this one this direction, and so on. Now I would let's go back top view. This tool allows me then to select one curve, which then defines the direction. And it will ask me which one I want to choose from. Now they should be all the same. If they're not, then this tool doesn't work. It doesn't work. Ah, now it worked. Yeah, now it worked. I did something wrong. So I maybe did it wrong. So if I do this. Okay, wait. Let's go back to our original problem. So we had these. Let's do the grasshopper again. Okay. Gonna do this here. Select all these. Oh yeah, we need a point. A point. That looks super weird. Of course, because this is not flipped and this is not flipped. So with that command, we can actually flip them. And we do this. Select curve to match directions. Okay, 1, 2, 3, 4. And press enter. And now it's fixed. And in Grasshopper, it works the same way. And by adding another tool here, so to sort it out automatically, you can actually do this. And so flip curve, if you put this in here, it flipped all the curves, but now it's the same problem as before. But here you have an option to put a guide curve, so you can actually do select. You can select one curve separately, or you do list item. You just use the first one, 0, probably is this one. Yes, this one. And use this as a guide curve, and then it does the same. So it uses that direction as the direction for all the other curves. The seam here is a bit strange because we haven't. So we need to do this actually. Pretty cool. That's adjusting seams. Let's keep that open. Maybe we need it again. So this is another very interesting tool, is the cross-section, curve from cross-section profiles. So I have these curves here in 3D space, and that tool allows me to draw, it tries to figure out cross-sections for these curves. The best way to show it, just to show it. So I would draw a line here, and it creates this cross section. Interesting. Or like this. I guess the more I draw, the more accurate this object becomes. It's remarkable. Now if I then choose these and loft them, just checking the seam. It also puts the seam on a similar spot, which is great. And then it fits through all the curves. Rebuilding curves. So for example, you have a curve, and at the moment it's like this, and then you make an offset. And remember, when you made an offset, you suddenly create all these crazy curves, these points, control points, which are really annoying. And there was this other option where you can offset loose, and it created something, but it didn't really offset it. It's not a uniform offset. So let's try this again. Offset. It's always the same distance, but it has all these crazy control points. So how to deal with that? The rebuild function can help you with this. I normally do this rebuild. So what that does, it gives me actually, it allows me to delete this curve I'm rebuilding. It tells me how many points it has, and it tells me the degree. I could change the degree, but I don't want. I want to be as close as possible, but reducing the amount of control points. Go and cancel and just check this one. This has 8 control points. Let's do this again. And what happens if I do the same here? Preview, you're gonna see the preview. So this is the maximum deviation is shown here. This is the maximum difference from the original curve and the new one. Then this would have also only 8 control points. Let's try it. Let's go back here, and then let's try it again. Now I could try to increase that, but see how the maximum deviation becomes lower and lower. So here we are getting quite close, but actually there was here, we were here with 14 already pretty good. And I have a curve which doesn't have so many control points. Clear. Rebuild curve non-uniform. That is also cool because it tries to rebuild it without an even distribution of the points. So it takes the shape actually better into account. And I could here say the maximum point count is 8, for example. And it tries to match it in a different way. Rebuild curve to a master curve. Select master curve. And I'm not sure what it does really, because it doesn't really does a good job, no? Let's put this away and let's try it again. So I try it like this. I go here, I want to see it. But here you can select the master curve. Select master curve. Understand. So what it tries to do is to try to match the amount of points. So for example, if I have 14 here, select master curve, it actually lowers the count, and let's try that. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. So it tries to match the numbers of control points. So let's show the other commands quickly. So let's, again, same problem. We have an offset, and we will try to minimize the control points without losing the shape of that curve. There's another way, is using the fit function. You can here try to fit the tolerance. So let's, for example, we put 1. It's actually pretty good already. It didn't change much. Can try even more. Let's do 2. So it tries to remove points. Of course, you can also go the other direction. Now this has 16 control points. I could use the same function here and say fit 2. Then they become pretty similar. You can change the degree of a curve. So you can also change it here, actually. You can change the degree of a curve. 1 would be just lines. 2 is already a curve, but it's a bit softer. 3 would be the same. And then the curve becomes stronger. And that's basically, you can also do here. You can choose the degree. That I'm not 100% sure. Select curve to fair, and you can choose a tolerance again. Sometimes just look into the help function. A fair command removes large curvature variations. Okay, so it's smoothing the curve a bit if there are large variations in the curvature. I see. So there are more often, the higher the tolerance, the less curved it becomes. And the last two ones, make uniform. So that's a question to you guys. I try to figure out what it does. I'm not sure. I'm really not sure. So if I'm looking at this curve here and I check the help function, and when I use this function, I mean, it's probably something similar. It tries to distribute the points better, I think. But when I use, for example, a circle, and I use a deformable a non-deformable. Okay, and then now I'm using a deformable. And let's do the same. Then this happens. I am not sure. If I do this with a deformable, nothing happens because it seems like that they're super equally distributed. There's also rebuild in Grasshopper. Offset. Let's do the same here. Grasshopper. So you can see it already is rebuilding stuff. So I have a trick when I do I have contour lines and I want to have an equal distribution of points to create a surface. Then it's very helpful. This tool is very helpful. I added a bit more curves, so it's more obvious what I want to show. If I want to create a mesh out of these, but the problem is that they're all very. First of all, some of these curves are smaller. Some of them are longer. Some of them have lots of points. Out of it have very little points. So if creating now a mesh from these points, it's going to be very messy. It's going to be a very messy mesh. Let's show you. I want to show you that. So here I have the curve. I have all the curves in here, and I extract the control points. And from these control points, I'm gonna build a mesh. If I'm gonna bake that, gonna bake it, then yeah, it's not very nice. It's not a very nice mesh. It has here a lot of points, and then here's just little points here, and so on. Let's go back. So what I can do, I could, of course, create points along the curve. That's possible. So instead of using the points, the control points, I could actually divide points, divide it like this. Or if I want to clean up the curves anyway, then I could use the rebuild function, rebuild the curve. And then what it does, so let's hide these, and then create a mesh out of it. So, and then get the control points again. It's still a bit weird. It's still a bit weird because it basically rebuilds every curve with the same amount of control points. So that's the problem. The smaller curve has 10 control points, but even the longest curve has only 10 control points. That doesn't work. So what we can do is actually measure the length of the curves. So I can say length. Then we get the length of each for each curve, and then we can divide that by the length, or by the length we want them to. So for example, we could say every 1 meter. We want to have every 1 meter, but because these are very long, these curves are very long, so you can actually see here 2000 meter. So I could say division, divide by 30 meters, for example. And now I put this in here. No, first I'm gonna make this, I'm gonna round it, or I just create a integer. So I'm gonna lose all the commas, and that I place into here, and that creates a very uniform distribution of points on my curves. And then I can try to make it even nicer and say maximum is 1000. And depending on how detailed I need it, I can then change the distribution. And then bake, let's bake it again. Bake invalid object, why? You're about to bake an invalid mesh. But why is it invalid? It's here. I don't get it. So now it's much more organized, that mesh. So last but not least, simplify lines and curves. That's also useful just to clean up your drawing. For example, you have something like this, and there are a lot of points in between which actually are not relevant or they're not needed because they're just on the same line. Then you can use the simplify function. The simplify function will delete all these extra points which you don't need. Okay, I think that's it for today. Please, again, subscribe, give me comments. I'm always open for improvement. If you have any question, let me know. If you have a better idea, especially this like make uniform, that could be interesting to better understand. If anybody has used it before, tell us what is it about this tool. Thanks for watching. See you next time.